Fifth grade lesson 8.4 is fraction and whole number division. So if we're splitting that fraction into whole number pieces, what does that look like? Our essential question is, how can you divide fractions by solving a related multiplication sentence? And again, these lessons are just preparing your brain, helping your brain see and understand why in future lessons you're going to use a reciprocal of a number, of a fraction. So this is just kind of getting our brains used to that idea so that it doesn't battle us on it when we get to that point. So we'll get some visuals to this. 3 friends share a 1/4 pound package of beads equally. What fraction of a pound of beads does each friend get? So if I'm looking at this, I know they tell us what to do here, but we really need to know how to set this up ourselves too. So this is a good place to practice. What is being shared? That's the first number of your division problem, and it's a 1/4 of a pound package. So if we had a whole package, 1/4 of it is the amount we're being shared. So that number comes first. Into how many pieces is it being shared? It's being shared amongst 3 friends. So we're dividing that into 3 equal pieces. So we have the rectangle representing a whole pound of beads. We only have 1/4 of the pound to share. So the rectangle is now divided into 4s, 1/4, 2/4, 3/4, 4/4 to make the whole. So 1/4 parts. When you divide 1/4 into 3 equal parts, you're finding one of the 3 equal parts, or 1/3 of just this 1/4. So we're ignoring these parts now. That's not what we had available to share. We only have available to share amongst our 3 people this. So we're doing everybody's getting 1/3 of that amount. We're dividing this equally into 3 equal pieces. And they want us to shade in one of those pieces. That's what one of the 3 friends will get. Okay, so if we want to know how much the shaded part is of the whole rectangle, we have to kind of say, how much is that of a whole pound? So we have to imagine these lines drawn out. There's 3 parts there, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each person is getting 1 out of 12 of the whole pound, 1/12 of a whole pound. So over here they say, hey, did you notice 1/4 divided by 3 is really just saying 1/3 times 1/4, because 1/3 times 1/4, 1 times 1 is 1, 3 times 4 is 12, is 1/12. Ta-da, ta-da. So remember when we were changing things to fractions, and let's say I had 1/4 divided by 3, I want that to be a fraction. Notice that this 3/1 is now a fraction, right? And notice its relationship to this. So division and multiplication are inverse operations, but remember also, fractions are technically division problems. So you've got some things going on where you can use this pattern to say, oh, okay, if I'm dividing 1/4 into 3 equal pieces, really I'm looking for 1/3 of that 1/4. So you can flip that over, and that's something in next lessons they're going to start talking about, is you just flip that over and multiply. Instead of trying to divide with fractions, you flip the second fraction over and multiply, use the reciprocal. This is just showing you why. Okay, so we had 1/4, we split it into 3 equal pieces, or multiplied this 1/4 times 1/3. So same thing going on, so each friend gets 1/12 of a pound of beads. Brad has 9 pounds of ground turkey to make turkey burgers for a picnic. How many 1/3 pound turkey burgers can he make? So we have 9 pounds of ground turkey. He's making 1/3 pound turkey burgers. So what are we splitting apart? The 9 pounds of meat. That goes first. Into how many pieces is he splitting that? He's splitting that into 1/3 pound pieces. So we're doing 9 split into 1/3 pound pieces. We draw 9 rectangles to represent each pound of ground turkey, and they've done that for us. Thank you very much. And we divide each rectangle into thirds. So we're dividing each of these into 3 equal pieces. You can go ahead and do that. Okay, and there we have done that. And when we divide the 9 rectangles into thirds, you're finding the number of thirds in 9 rectangles. So 9 rectangles into thirds. You're finding the number of thirds in 9 rectangles, or finding 9 groups of 3, because there's 3 in each group, right? There are how many? I'd have to count them out. 3, 6, 9, 12, 15, 18, basically 3 times 9, which is 27 thirds. So we can complete this number sentence, and they're just helping us recognize If I have 9 divided by 1/3, I'll change that, just to get you in that habit, change that to a fraction. 9 over 1 times 3 over 1, or 9 times 3. And I'm going to get 27 over 1, which is just 27. So again, we're coming down to that, flip that second fraction and just multiply. Is a future lesson coming your way when you're dealing with division with fractions? You change them all to fractions, you flip the second fraction and multiply, and you're using all the same multiplication steps. But this is helping us see why. If my second fraction is a whole number, I ended up with a tiny amount. I'm sorry, if my divisor is a whole number, I ended up with a tiny amount. If my second number, my divisor, is a fraction, I ended up with more of what I was looking at there when I was dividing it with a whole number. Let's look at another example to let our brains marinate on this. It's just something that takes a little bit for your brain to get used to. Don't worry if it's not all the way clear yet. You have learned how to use a model and write a multiplication sentence to solve a division problem. We're going to practice some more. We have 1/4 divided by 2 equals 1/8. Okay, they are saying this is, before I go to that, I'm going to model it. So we have 1/4. So if we have the whole thing and we cut it into fourths, we'll highlight that in red. 1/4 of that is this amount of the whole thing. Now we're taking we're dividing this 1/4 piece into 2 equal pieces. That's why they drew this line right here, is to cut these into 2 equal pieces. And one of those pieces, let's do that. One of those pieces is 1 out of 1, 2, 3, 4, 5, 6, 7, 8 pieces. 1 out of 8 total. That's the answer to that modeled. If we took, I wish they had set this up differently, honestly. They say you're doing half of 1/4. Half of 1/4, you're doing half of the 1/4 piece. But because I'm helping to try and tie it to where you're going with this, I would keep that first section the same, 1/4. And I would take this 2 over 1 and flip it over to 1 over 2. I'm still doing half of 1/4, and I will get 1/8. We have 4 divided by 1/2 equals 8. Well, let's see. We have 1, 2, 3, 4, and I'm dividing those 4 pieces into half-size pieces. There's 2 pieces there now, there's 2 pieces there, 2 pieces there, and 2 pieces there. So I could just do 4 times the 2 I get from each of them, and 4 times 2 is 8. If I change to fraction, just so that if you're making sense of this, then this step is going to be easier later. This is 4 over 1, and I'm doing, cutting them into half, but giving me 2 pieces, so that's why I'm switching this over. 4 times 2 is 8 over 1. 4 times 2 is 8. They say, look at example A, this one, and describe how the model shows that dividing by 2 is the same as multiplying by half. Well, when we took our 1/4 that we started with and we divided it into 2 pieces, we were given 1/8. The whole thing is 8. So when we split the 1/4, that gave us 1/8 of the whole rectangle. We were focused on the 1/4 because that's what we started with. We split it into 2 equal pieces, and that gave us just that little bit. Now let's look at example B. Describe how the model shows that dividing by 1/2 is the same as multiplying by 2. When we were given 4 whole candy bars and we were splitting them into half-size pieces, how many little half-size pieces do we have is really what they're asking us. So we had 4 pieces. We split them, all of them, into 2 parts. So now we have 8 pieces. When you divide by whole numbers greater than 1, the quotient is always less than the dividend. For example, the quotient of 6 divided by 2 is less than 6, and the quotient for 2 divided by 3 is less than 2, always less than that. But we're going to pay attention to, in the next section below, how the quotient compares to the dividend when you divide fractions and whole numbers. So let's take a look at that. Okay, so yeah, our brain has gotten used to the fact that when we divide with whole numbers, we're cutting it into smaller pieces, right? But let's take a look at what happens when we're dealing with the fractions. We've already looked at this before. This is really just kind of bringing that to the front of our brains again. If we have 1/2 and we're dividing that into 3 equal pieces, let's draw a whole amount, and then we're going to cut it into half. We're really only focusing on that 1/2 of the whole amount, 1/2 of the whole amount, and then we're cutting that up into 3 equal pieces. And of the whole amount, if I split that into 3 equal pieces, now I have this amount right here, I get 1 out of all 6 of these all cut up pieces now. And that is smaller than the 1/2 I started with, right? Also, we could call that 1/2 times 1/3, and we get 1/6. That's how we get that. Okay, so we get smaller than dividend. We started with half, and we're like, yeah, I got half a candy bar. And then they said, oh, but you have to share it with 3 people. I'm like, oh, man, now I only get 1/6 of a candy bar. Okay, let's look at this model. We have 3 whole candy bars. All right, 3 whole candy bars, yes. But you're going to split those in half. So we're going to split those in half so that we can hand them all out. How many half-size candy bar pieces? That's what this is asking. If you have 3 full candy bars and you're going to cut them into half-size pieces, how many half-size pieces will you have? 1, 2, 3, 4, 5, 6. I will have 6 half-size pieces. So 6 pieces that I can hand out. This is the same as saying 3 times 2, because we have 1, 2, 3 candy bars, but each of them is worth 2 pieces. Or 3 over 1, oops, is a fraction, times 1/2 flipped over. 1/2 flipped over is 2 over 1, and that's going to give me 6 over 1, which is 6. So 6 pieces is what I get, and 6 is larger than the dividend. So if we are dividing a fraction divided by a whole number, we get a smaller value. So when I divide a fraction by a whole number greater than 1, the quotient is smaller than the dividend. And when I divide a whole number by a fraction less than 1, the quotient is larger than the dividend. So there's a little bit of readjustment. Our brains understand division makes numbers smaller by now, but there's a little bit of adjustment when it comes to working with fractions. Once our brains adapt to that, they go okay with it. Let's look at the share and show. Question number 1 says use the model to complete the number sentence. I have 2 whole candy bars. They've been split into 1/4 pieces. This is the same as 2, and then if we flip that over, it's 2 times 4. There's 1, 2, 3, 4 pieces here, and 1, 2, 3, 4 pieces there. So 2 times 4, and 2 times 4 equals 8. That's just representing how many pieces I now have. So that's how that models out. Let's write a related multiplication sentence and solve, and we're going to model it too to let your brains adapt to this. We have 1/9 divided into 3 equal pieces. Let's just make that a fraction. The number sentence I'm going to make as a multiplication is 1/9. I'm going to flip this over. It's reciprocal is the word you'll hear later, and I'm going to make that a multiplication problem. This is saying I have 1 whole candy bar that is currently split into 9 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretend those are 9 equal pieces. I'm only focusing on 1/9 of it, and I'm dividing that into 3 equal pieces. That's what this is saying, divide that into 3 equal pieces. I've done that, and of course I have to imagine that I've divided the whole candy bar that way across the way. So 1 out of 9, 12, 18, 9, 18, 27. 1 out of 27 is all I'm getting of that. So you get 1/9 times 1/3 is 1/27. 9 times 3 is 27. So that's how you can switch this around to become that and do your calculation without the model. Now we have 7 divided into half pieces. So that's like having 7 whole candy bars. There's my 7 candy bars. And I'm cutting them into half-size pieces each. So how many pieces do I have now? Well, I have 2 pieces for each candy bar, and there's 7 of them. So it is 7 times 2. If you're wanting to see that, preparing you for reciprocal, we had 7 as a fraction, 7/1. Multiply it by the reciprocal version of that, the flipped version of that. And basically that is 7 times 2. 7 times 2 equals 14. Oh, this one was 1/27. So that's how you do this lesson. I hope I made that clear enough. Use the book to help you through the things central. You might need the examples in front of you, but I think you'll be all right. Good luck.